Hi everyone, I am Matteo Salvarezza.
And I'm Meghan Rieu-Werden.
So our talk is titled Fantastic Neural Networks and Where to Find Them, and we are going to talk about this new product, which is the Wolfram Neural Net Repository, a system for distributing and accessing easily neural network resources. So good morning everyone, I am Matteo, she's Meghan. And we are here to tell you about this fantastic new product, which is the Wolfram Neural Net Repository. It's been quite an effort to come to this point, but this is now released. And so Meghan will start giving you an introduction about what is it.
Okay, so basically a little bit of background for why we have this. So it's comprehensive. We have a large assortment of high-quality net models there, which are updated regularly. And also, all of the models are pre-trained, which saves you training time. And also, some of the training sets are not publicly available, so it would be difficult for you to train your own net exactly the same way. And the last thing that's really nice about it is that everything is within the Wolfram language. So there's no need to import from other frameworks. You can just go right there, get the model that you want. You can use it as is if you'd like. If not, you can take it apart, take certain layers out, add them to other things, make new models of your own, or do different things with the models that are there. All of the models all have both a trained network and an untrained network. And so if you'd like, you can take the untrained network and train it with different data. And then lastly, you can submit your own, which we'll talk about later on in the presentation. So this is the actual data repository, neural net repository, sorry. So as you can see, everything is organized by task type. And then, I don't know if you can see, but there's also a little subtitle that tells you the purpose of the network sort of more specifically. I don't think, yeah, we don't have it, it's not linked, but it will be linked from the regular data repository as well. You can actually, it's live. You can just go to that web address. Oh, sorry. Nope, but I'll put it there. Yeah. Okay.
That's because it's a soft release.
Yeah.
It's not like full release, so it's not being advertised yet.
Yeah.
Yeah, of course.
Yeah. So then, in addition to being organized by task type, you can, by task type, you can also, like, there are little icons here that you can see which which input domain it is. So whether it's image or text, or there will be audio and numeric as well, but we don't have any yet. So if you just, I think so. Bob showed some of this yesterday, but here it is again. So there's a certain amount of metadata that goes along with the network, and so it'll tell you a little bit about the purpose of the net, and then some background about it, some training information with links to the data sets that were used if they're available. You can also download the example notebook or just look at the examples on the net, and you can download the construction notebook as well, and then there are references. Here, let me okay, so let's start with some examples. So we'll start with an image, and then grab the so we're going to do classification first. So we'll start with general purpose object classification. So this is the Wolfram image identify net. And then let's see what it identifies this image as. Right. So that's correct. See the top 5 probabilities here.
So this kind of networks for general purpose classification are like they play a central role in computer in deep learning applied to computer vision. They're basically used as a building block for a lots of more fancy applications, and they are very powerful. They usually train on huge data sets, the major one being ImageNet. So for this category of models, we have like quite a few. I think we have like around 10 models.
Yep.
They're all so most of the stuff in this repository are actually portings of like state-of-the-art officially released models from other frameworks into our own framework. So if you're familiar with, you will find a couple of versions of GoogleNet, you will find VGG16, VGG19, ResNet, and more stuff will come. The image identify network is for now it's the only network which is not a port of a external model, but it's something made by us. But more stuff like that will come. And yeah, so here's another one. So this is this is a fine tune of the Inception V1 network trained on the ImageNet datasets on a new dataset, which is a kind of a common practice in deep learning. So this thing was trained on this dataset called the Extended Salient Object Subitizing dataset, which is basically a dataset about counting how many objects are in an image, regardless of their nature. And so that it's kind of working fine because they say there are 2 guys there, and you can see that these are the probabilities, and you can see that it's pretty confident that there are two objects there. It's 99% probabilities. So on to the next guy. This is so same architecture, Inception V1, so GoogleNet, very famous. This was trained from scratch on the Places 365 dataset, which is not an object recognition dataset like ImageNet and so on, but it's a scene recognition dataset. So it basically tells you not the object in an image, but like where is it? Like it has some classes like, I don't know, like living room,
classroom, auditorium, mountains, rivers.
Yeah, exactly.
So let's see.
Yeah, that was a hard one. I didn't believe that that stuff had that star among its classes, and so it's quite not sure what's happening there. Bar Music Studio. Okay. This may be probably even a tougher one because this is supposed to show you the location on the Earth a photo was taken, so it probably doesn't have the location of the Death Star as well. Okay, let's see
where that is. New York City.
Okay. Interesting. Yeah.
So
as with the other networks, we can take the top probabilities. Here we're taking the 50 most confident locations, and okay, it's somewhere in Europe or in the US or
perhaps South America.
Yeah, perhaps. Who knows? Okay, so gone. Yeah, I'll tell you how this dataset is constructed. So basically, actually, this is a massive dataset that's composed of like millions of images, and they were annotated with the actual like latitude, longitude the peak was taken. Those locations were then like put in a grid of like it's 15,000 locations around the Earth. And so basically the data set were composed by pairs of image and the index on one of these 15,000 locations. And you can see it here. Let's scroll up.
Sorry, my scroll goes
okay. Can you see this? This is the last layer. This is the last softmax, and the dimensionality of the softmax is actually 15,000. Can you see this number? Okay, so this is a classifier. Okay, so it tells you how confident it is for each location that that peak has been taken in that location. So what we did here is we took for this Han Solo and Chewbacca image, we have taken the most the 50 locations the network is more confident, and we've plotted them with the size of this circle being proportional to the probability to how what the network is. And sorry. Yeah, at least. But the top one was New York City for some reason, as you can see, and it's basically the biggest circle here. That's why you get New York City if you don't specify even the top 50 probabilities, but you only say, just tell me where this peak was taken. It's picking the maximum automatically, but you can ask for more information.
All right, so we'll move on to image processing.
Yeah, so we have besides classification, we have these are more about more fancy tasks. So what is this?
So this is the colorization model.
Colorization. So this was another pretty much state-of-the-art model. So this thing is we call this raw model, as you can see here. So what does it mean exactly? So we are tagging as raw models, basically models which will not give you the final result straight away, but you have to do some more work on that. This will change in the future because we're good. So basically, this is for models which need like some processing, like outside neural net processing. So you get the output for neural networks, but in order to get what you actually want, which is the colored image, you have to do a bit of work. This is actually not. Just do it again. Yeah.
Oh, okay.
Okay. So in this case, this thing is outputting the A and B channels of the LAB color space. So we gave a grayscale image in inputs, and it will output the A and B channels of the colored image in the LAB color space. So what you have to do is to merge them with the luminance from the original grayscale image. And that's what that evaluation function is doing. This will change in the future. So this thing will be bundled inside what you get by doing that model. But right now, we still don't have support for that. So we're tagging these guys as raw models. But they will be updated in the future. Okay, so let's move on. This is depth estimation model. So this will pretty much self-explanatory. Will produce you depth map, and you can do nice, cool visualization of that. And you can also superimpose the original image, so you get a 3D representation of those two guys. That's a very cool one. So if you've never seen style transfer in your life, it will blow your mind. Wow. And this thing is one of the methods for the built-in function image restyle, which we are going to compare with. It's not exactly the same. I can tell you why if you're curious, but you can see that, it's almost the same. Yeah, the point is that it adapts the network to the actual size of the image, while the vanilla network has fixed size input and outputs, and so it gives you a square image. You can change it in the framework, like you can resize the network and do it, and image restyle does it for you automatically. That's it. Then image restyle has other methods, but we won't talk about those now. Okay, so here's another fun part. We have quite a few networks for facial analysis, and luckily, Find Faces also found Chewbacca's face. So we are going to run all these facial analysis network on both.
Yeah, so they only work on really facial crops.
Yeah, so the fun part is that, what will happen when they see Chewbacca's face, which is not actually a face. So this thing tells you the age, and it's pretty much failing for Han Solo too. But nice thing you can do with this model is that you can actually visualize, the histogram of probabilities for the age. So the blue thing is Han Solo and the red thing is Chewbacca. So strange, this doesn't happen often, but you see that for Han Solo, it has like two peaks. The biggest one is it was slightly bigger. It was at 13 years old, and then there is a peak around what's 50 or something.
Yeah.
So like the average was probably the right one for that peak. While Chewbacca is peaked at 13 for whatever reason. Let's move on. Gender prediction.
So this is pretty accurate.
Oh, amazing.
And
And you can see that for Han Solo is pretty, it's pretty sure it's a male, but for Chewbacca, not so. Who knows? Then we have facial key points model. So this guy is very simple. It's telling you the position of the eyes and the nose and the mouth, but actually two much more powerful models were just brought in. So we don't have them here, but you will find them in the repo. And they will identify 68 key points per image. And that's pretty accurate for Chewbacca as well. This is very cool. This is the last one we're showing you. This is for basically from an image of a face, it will regress a 3D facial model. So I've cheated here because like I'm using a facial crop of slightly bigger size than what Find Faces produces, because otherwise it wouldn't detect Han Solo's face. You can rotate this guy, like you can show this thing. And you can extract. So this is a 3-dimensional array of pixel intensities, which you can show with Image 3D. And you can extract the facial 3D mesh as well from that. And you can rotate that as well. Okay, so this super quick rush is over. And now we're going to take questions.
No,
actually, no, sorry. Sorry, Meghan.
So in addition to being able to use what's already up there, you can submit your own if you'd like. So we have a nice definition notebook for that, which is not live at the moment, but will be soon. So if you're really antsy to submit your own right away, you can go ahead and fill out the notebook and then send us a message on the Contact Us part of the repository, and we can figure out how to get it in there. But this will be up very shortly. So there's a certain amount of metadata that you can add here, and then you can indicate the task type and the input domains. And then there's a preparation area, so if you'd like to just do everything right in the notebook, you can do that. Or if you want, you can just like upload a cloud object or a local object or something like that. Really, all you need to add in is the trained net here. And then you would put in whatever examples you want to show. And then if you want to put a link to your testing data, you can put that as well. And then you should provide a construction notebook as well, which you can either upload here, or you can do it longhand like the example notebook where you put everything in here. And both the example notebook and the construction notebook will be turned into, anything that you put in here will be turned into a notebook that can be downloaded straight from the repository. And then you would create your resource object, and if you can either deploy it locally, you can deploy it to the cloud if you'd like, share it with other people, or if you'd like to submit it, you would need a publisher ID, and then you can submit it to the repository. Probably within a week or two, max. And then we can take some questions. Yes.
So it's networks will run on any hardware. Of course, so for deep learning, GPU is important, but you're not tied to GPU. And so this is the purpose of this repository is mainly to give you models which are ready for evaluation. It's not about retraining models. These are pre-trained models that you can use. So the part where GPU is very crucial is training. So of course, GPU evaluation is faster than CPU evaluation, but okay. Next one. Yeah. So we are by the most recent standard, you probably mean CUDA 9. So no, the perspective is different. So when you're using these kind of models, you don't have to care about all these GPU stuff at all. If you have an NVIDIA GPU with the correct drivers, it will just run. We are bundling the CUDA installation inside the product, and you don't see it. It's transparent to the user. So usually in external deep learning frameworks, you have to set up CUDA yourself. So you have to download the correct version of CUDA. You have to compile it. You have to link it to whatever frameworks you're using. It can be MXNet or Caffe or Torch or whatever. And you have to do this stuff yourself. Here, as soon as you install Mathematica, everything just works. So as for the version of CUDA, we didn't hook up CUDA 9 yet. We are running on CUDA 8. We'll hook up CUDA 9 soon. But anyway, as soon as you have a working NVIDIA GPU with the correct drivers, it will just run using whatever version of CUDA we bundle in. So you don't have to care about nothing. Yes. So if you want to run on GPU, there's an option for network evaluation. It's do net of the input, comma, target device goes to GPU, and it will run on GPU. So it's very simple. Go on. Well, that's another approach to 3D facial model regression, but this guy is more powerful. He can do it with one. Then, of course, you may argue, okay, if I have two, I may get better results, of course, but that's not what that model is designed to work with. So that thing only is designed to work on a single image and produce a 3D volume. Then, of course, you may find like other models which needs more data and will possibly be better, but that's the only 3D facial regression model we have yet. But like this project, it will be evolving constantly. So there are about 40 models in the repository now, but it will just grow. So you may find some for that as well in the future.
Great question.
Passion. No. So our policy for accepting external submission will be basically that we will only check that the metadata and like the submission is formally correct, so it has the correct metadata, it has what is needed to have, like the files and the examples, and that's it. And possibly not being a network about a completely ridiculous task, but we are not basically checking for the performance of the external submission, because that will be a very time-consuming task, and it's also kind of outside the scope of this, because it's more about sharing. So even if you had something which it's not, the best thing is in the world for the task, but nevertheless you want to share with the outside world, you can submit it, and if the submission is formally correct, we'll accept it. No, there is no rating system, but that's a good idea. We were thinking about that too.
Yeah, and any suggestions like that, you can submit to the contact us, and yeah, we'll take them into account.
So in deep learning for computer vision, usually what people do usually is working on images between 200 and 500 or 600 pixel size, depending on the task you have to do. So for general purpose classification, so like ImageNet models and so on, the usual size is 224. So that thing has enough, like a 224 by 284 image has enough information for the network to figure out what's inside it, basically. For different kind of tasks, you may want slightly higher resolution, like for example, image processing tasks, like for example, I don't know, the this, yeah, exactly, the style transfer network. For those kind of tasks, people usually shift to more like bigger sizes, but it doesn't really make much of a difference.
Yeah, I mean it depends, but yeah, if you use really low resolution images, it
Yeah.
won't look very nice, but
But
it still
usually,
works.
like, it's very rare to find something which was trained and it's supposed to be evaluated on 1,000 by 1,000 images. Just because it will bloat your memory usually. Yep, imagery style thing. Yeah, yeah. So okay, we move on to. I'll check that with you later. But so usually, so this kind of processing is very intensive processing. So running a deep network on a very big image can easily bloat your memory, either GPU or CPU memory. So that's more or less no surprise. But I'll check it. I'll check in detail with you. That's a tough one. So
Depends how quickly you submit them.
that's a nice one. So for our side, it took about 8 months to get those 40 models, but of course we got much better at doing it after some time. So there was like a slow transient. So it strongly also depends by the internal effort of the company, like how many people work on that, which is quite of unclear. But I mean, it's something we care about.
And we are trying to get more people to work on
Yes,
it, so.
exactly. We are trying to get more people working on this. So this will definitely. I would expect probably 10 models a month or something like that. And that's for the conversion part. So you take a state of the art, release open source network done by someone else, and you import it in the framework. Then after some time, we will start doing training ourselves for internal purposes, and some of these networks we train ourselves will be also released here. So that will probably get, it will get fast after some point, after we also start adding our own models to this.